All right, welcome, and I am glad that you guys are here again today. We are starting a unit on our geography basics. This basics unit will be going over the content standards for the state of West Virginia, and we will be focusing in today on 7-Eleven. No, we're not talking about the place where you go get a big gulp. Instead, it is basically on location and time. So today we are focusing in on location and time zones. First off, I want to explain that there are two types of location. You have absolute location, which uses longitude and latitude. And then you also have relative location. And relative location is actually very important because it allows us to describe where a place is in relation to another place. For example, Parkersburg is an hour north of Charleston off of I-77 at the confluence of the Ohio and Little Kanawha rivers. That is a descriptor of the city of Parkersburg, and most of you probably understand that because it's describing places you've heard of before. Charleston, the Ohio River, the Little Kanawha River. These are all places that you are aware of. However, it's not exact. And when we need an exact location, we use latitude and longitude. Now again, we are not familiar with latitude and longitude, most of us, to understand where an exact place is simply by latitude and longitude. For example, if I said 38 degrees north, 81 degrees west, most of you probably have no clue what I'm speaking of, at least not just generally. However, that happens to be where Parkersburg is. So both these kinds of locations, relative and absolute, are necessary to help you read maps and understand where you are. Let's take a look at absolute location. First off, latitude. It's always latitude and longitude. Latitude tells us how far north or south of the equator we are. And latitude and longitude are both measured in degrees. The equator is at 0 degrees, and the North Pole is at 90 degrees. And every place in between is going to be some place in between with latitude. Now, why do we have 90 degrees? Well, it's actually a math question. If you go from the equator to the exact core of the Earth to the North Pole, what angle would that form? Well, that's a 90-degree angle. That's a right angle. And because of that, that's why the North Pole is listed as 90 degrees north, north latitude. Meanwhile, the South Pole also forms the same kind of angle. You go from the equator to the exact core of the Earth to the South Pole, you will find that that is also a 90-degree angle. So the way we differentiate that is with a capital letter N and a capital letter S. We would write that as 90 degree symbol, capital letter S. That stands for 90 degrees south latitude. Now, places in between are the angle between the equator and the exact core of the Earth. So I already mentioned that Parkersburg is 38 degrees north. For the sake of discussion, let's just round that to a nice even 40 because that's an easy number. So if you were going to go to the equator and you were hypothetically able to core down to the exact center of the Earth and then core up to around where we are, that would be 40 degrees north. 40 degrees north. And that's why we're listed at that latitude line. There is also a 40 degrees south, and it's all places south of the equator that are 40 degrees from the equator to the exact core of the Earth back to the surface of the Earth. Longitude is measured in degrees as well. However, there are 180 degrees west longitude and 180 degrees east longitude. And the reason for that is fairly simple again. It's half a circle. A circle is 360 degrees. Therefore, half of a circle is going to be 180. Now, there's a problem when we're measuring east and west. And that problem literally is, where does east begin and where does west begin? Think of a round ball. Where is the middle of the outside of a sphere? The bottom line is, there is no middle of the outside of a sphere. That's why we use a ring when we get married, because a ring has no beginning and it has no end. It's supposed to represent undying, unfailing love that will never end. When we are looking at the outside of the sphere of the Earth, we have the same problem. There is no middle of east and west. So in the 1880s, these great men met at the Royal Observatory in London, England, and they just were discussing this matter. What should we do? Where should east and west begin? And somebody got the bright idea to vote for the place that they thought was the most important in the world at that time, literally where he was standing. He was standing underneath the middle of the A-frame roof of the Royal Observatory in Greenwich, England. Greenwich looks like Greenwich, but it's Greenwich. Greenwich is located just outside of London, and that is where the prime meridian goes. So it goes from the North Pole over the Royal Observatory in Greenwich, England, to the South Pole. Everything west of that building is in the Western Hemisphere, and everything east of that building is in the Eastern Hemisphere. So if you go from the Royal Observatory to the exact core of the Earth and come back out to where you are, that forms an 81 degree angle, and that's why Parkersburg is listed as 81 degrees west longitude. Lines of longitude are numbered east from the prime meridian to the 180 degree line, and west from the prime meridian to the 180 degree line on the other side of the Earth. And that line on the other side of the Earth is called the International Date Line. We'll get to that in a second. But all places in between the prime meridian and the International Date Line going west are in the Western Hemisphere. We live in the Western Hemisphere. Meanwhile, all places from the prime meridian going east to the International Date Line are in the Eastern Hemisphere. The Eastern Hemisphere is where you find Asia and East Africa and Australia. Now, you have the International Date Line, and literally the day changes at the International Date Line. When I'm doing this recording right now, it is Monday afternoon. But if I were to travel west and cross the International Date Line and go to Japan, it's very early Tuesday morning. The date changes. The reason for this was first made known by the trip of Ferdinand Magellan and his crew. Ferdinand Magellan actually did not finish that trip, but his crew was the first crew to circumnavigate the globe. They traveled west until they ended up back in Lisbon, Portugal. They started in Lisbon, Portugal. They ended in Lisbon, Portugal. And they went clear around the globe. There was a problem. When they got back, there was a day missing. And at first, they were actually accused of murder because there was a day missing from the log. How could there be a day missing from the captain's log? Well, as they traveled westward, their days were slightly longer than everybody else's. And eventually, they were 24 hours ahead. Think about it. If you go west and come back, you're 24 hours ahead. What needed to happen was a day needed to be added to the calendar. Today, in our fast-paced world, we have this line called the International Date Line that runs through the Pacific Ocean. If you are going from the Americas to Asia, you add a day to your calendar. For example, right now in East Asia, it is Tuesday. It is Tuesday there. Meanwhile, when I'm doing this recording, it's Monday here. If you're going from Asia to the Americas, it's the opposite. You lose a day. So somebody coming from, let's say, Australia to Los Angeles, when they cross the International Date Line, they fall back a day. So it's Tuesday in Australia, but if they were flying to here, when they cross the International Date Line, it would go from Tuesday morning to Monday night. The International Date Line generally runs along 180 degrees east-west. However, as you can see in the picture, it's not a straight line, and this is because we do not want to separate countries. By combining latitude and longitude, we can pinpoint any exact location on the Earth, and that's why absolute location is often referred to as exact location. So, if we were to use latitude and longitude, what do we put first, and how should it be written? We always say latitude first. Always. So it's going to be degrees north or south. Then it will be degrees east and west. Look at the map below and you see Detroit, Michigan. Detroit, Michigan is 42 degrees north, and it's also 83 degrees west. Now, it would be incorrect to say Detroit's exact location is 83 degrees west, 42 degrees north. That is backwards. When we say it, we always say north-south first. 42 degrees north, 83 degrees west. This is always the way that it's stated every time. When we write it down, we would write it down as 42 degree symbol, capital letter N, comma, 83 degree symbol, capital letter W. You always use capital letters when you're dealing with direction. Now, North America is in the northern hemisphere because it's north of the equator. It's also in the western hemisphere because it's west of the prime meridian. Now, not every place on Earth is exactly on a degree line. So how do we break down degrees into smaller pieces? Well, each degree is split up into 60 minutes. And then each minute of a degree can even be split down into 60th of degrees called seconds. Then each second can be split into tenths and hundredths. This is pretty much the same as our time system, and you will find out later in the year why this is the case. Now the world is 360 degrees around because it's a round sphere. How many hours are there? That's right, there are 24 hours. And so since there are 24 hours, the high noon, or the high point in the sky, originally used to determine what exact noon was. Now this was not a big deal until the late 1800s when we start having trains going across the United States. And if you start thinking about it, high noon is not high noon everywhere. It's only high noon at one particular spot on planet Earth. And train conductors had to know high noon literally at every location along their route and figure out what time they were going to get there and what time they were going to leave. Well, this became a problem. And to deal with this problem, again, at the Royal Observatory in London, these smart men came up with an idea. Why don't we just split the Earth up into 24 zones called time zones, each of them being approximately 15 degrees apart. 24 times 15 is 360. And so that's what was decided. And today, when you go from one place to another, everything within one time zone is going to be the exact same time. It's 12 o'clock in Parkersburg, it's 12 o'clock in Clarksburg, it's 12 o'clock in Cincinnati. Where before, if it was 12 o'clock in Parkersburg, it was 12:03 in Clarksburg, and maybe 11:53 in Cincinnati. Now we're all in the same time zone. However, once you cross that time zone, let's say you go to Chicago, the time falls back 1 hour. As you move westward, the time would fall back 1 hour. So, for example, if it's 1 o'clock here in Parkersburg right now, it would be noon in Chicago. If you go to Denver, you cross 2 time zones. You're in the Mountain Time Zone, so it would be 11 o'clock there. And out in Los Angeles, in the Pacific Time Zone, it's 10 a.m., even though it's 1 p.m. here in Parkersburg, West Virginia. Greenwich, England is the starting point for time zones, because that's where the prime meridian is. A real cheesy saying to help you remember. East, increase. Time is forward to all places to the east. West, less. Time is backward to all places to the west. So like I said, if it's 1 o'clock in Parkersburg, it's 10 a.m. in Los Angeles. Meanwhile, if it's 1 p.m. here in Parkersburg and we go east, we increase. For example, London, England, if it's 1 o'clock in Parkersburg, you go across 5 time zones to London, England. So it is literally 6 in the evening in London, England, when it's 1 in the afternoon here in Parkersburg. All right, so let's look at the map. Again, generally speaking, time zones are 15 degrees apart. So for the sake of discussion, let's say you're at position D. What time is it at position C? Well, it's west less, and we're moving 60 degrees to the west. So, generally speaking, C should be at 4 p.m. Let's say it's 1 p.m. at X. What position would it be 5 p.m.? Well, east increase. So we increase 1 hour per 15 degrees. B happens to be Louisiana. So if at point X in Alaska, it is 1 o'clock. In Louisiana, it would happen to be 5 o'clock. The Earth rotates west to east, and solar time is based on the position of the sun as night is falling on the Earth. Look at the east coast here. And one of the things I like about this map is you can see not only where the cities are here in the United States, in the eastern part of the United States, you can also see the relative wealth. For example, look where Boston and New York, Philadelphia and Washington are. That is the financial and government center of our country, and you can see it's lit up very bright. That region is known as the Boswash region, and at night you can see the lights everywhere. You can also see Miami down there in South Florida, and Houston and Dallas over in Texas. But if you look very carefully, you can see a light that is basically the Parkersburg, Belpre, Marietta area. The arrow I have pointing to it, but you have to look very carefully. You know why? Because Parkersburg, Belpre, Marietta is not nearly as populated as the other cities I mentioned. All right, now let's look at this again. So here we can see Spain and England are still in the daylight. Meanwhile, it's dark and the sun has set in Italy. Meanwhile, sunset is going on in France. And this is all because of the rotation of the Earth. All right, I hope this helped, and have a wonderful day.